Hi, my name is Ethan Rejto, and I'm an engineer here at Desktop Metal. Today, I'm going to be giving you an overview of the Desktop Metal Studio System, which is the world's only office-friendly metal 3D system. This allows you to create complex metal parts in a variety of materials, all from the comfort of your office. The Studio System consists of three pieces of equipment. First, you have the printer, then the debinder, and finally, the furnace. The entire system is controlled by Desktop Metal software Fabricate, which is where the entire process begins. So let's go ahead and take a look at that. So think of Fabricate as the brains behind the Studio System. It's going to control each of the three pieces of equipment through the entire process, which makes the system extremely easy to use. In the next video, I'm going to be going through a lot more detail on Fabricate. But for now, let me show you just how easy it is to prep your model, and then I'll let the software automate the entire fabrication process, from printing all the way through sintering. So we'll just go ahead and import our part. Fabricate will automatically generate the toolpath for printing, while also setting debind and sinter cycles based on the part's geometry and material. From there, we'll just go ahead and send it over to our printer. Now let's go ahead and take a quick look at how the printer works. The printer is very similar to a plastic FFF style printer. And by this, I mean that media is extruded through a nozzle and the part is printed layer by layer. However, instead of using plastic filament, the Studio System heats and extrudes bound metal rods, like this one here. This rod is a combination of metal powder and binder. As the rod is extruded, the binder is what's being melted, and the metal powder just comes along for the ride. In other words, the binder acts as a medium for the metal powder to be laid down in the correct locations for the part to be printed layer by layer. You may notice that there are two extruders on the printer. The one on the left prints our bound metal rods, while the other extruder over on the right side is responsible for printing the ceramic release layer. And I can show you what that looks like on this green part here. More on what a green part is in a little bit. But for now, what I want you to notice is this white layer here. That's the ceramic release layer that will ensure that after the sintering step, we're able to remove our supports by hand. So I just mentioned the term green part. This is what you end up with at the end of the printing process. It's still pretty stable, but it's not quite a metal part yet. That's because the part still contains binder. This binder is going to be removed during the debinding and the sintering step, and first up is the debinding step. In the debinding step, the part is placed onto a tray and lowered into the tank, where it's going to be immersed in a debind fluid. This is going to remove the wax portion of the binder, and again, this process is completely controlled by Fabricate. Once this process is complete, our green part is now referred to as a brown part, and it's ready to head into the furnace for the final step of the process, sintering. With the brown part correctly positioned in the furnace, it will be heated in a sintering cycle, which is fully controlled by Fabricate. During this heating process, the remaining binder is evaporated and the metal particles fuse together. As you can see here, the part's going to shrink by about 15%. This is due to the metal densifying in the furnace. What you're going to end up with is a strong metal part. Remember earlier when I talked about that ceramic release layer that's going to make taking our raft and supports off extremely easy? After the sintering process, our ceramic release layer simply turns into this pink dust. Now, all I have to do is twist our part and release it from its supports. That makes it super easy. The Studio System is capable of printing a wide variety of alloys, including 17.4pH, alloy 625, copper, H13 tool steel, and many other alloys our materials team is working on for future release. I encourage you to watch the follow-up videos that are going to dive deeper into the functions of the software, the printer, the debinder, and the furnace. In the meantime, be sure to head over to desktopmetal.com for more information.